All right, guys, let's just go right into it. First, we define the difference between implicit and explicit. Explicit is a function that is described clearly, like y equals square root of x. That is explicit. And an implicit equation is in the form of y squared equals x. Not all implicit equations can be written explicit. Let's see if we can do example one. So example one, we're just going to take the derivative immediately. Now notice what it says. It says dy dx. So it says to take the derivative. Here's what we're really going to be focusing on. To take the derivative with respect to what letter? X. So here's how you do it, guys. This y squared is not an x. So when you take the derivative, here's what you're going to say. The derivative of y squared is 2y, but that's not an x. dy dx equals, and then the derivative of x is just 1. And that's it. Now, you're going to get dy dx by itself. How do you do that? Divide by 2y, divide by 2y. So dy dx equals 1 over 2y. And you're done. That's the answer, guys. If you want to think about this as chain rule, it kind of is. It kind of is. Like the derivative of y squared, 2y, y prime. See, that's the derivative of the inside. Equals, and then 1 dx dx. But yeah, it kind of is, guys. It's like chain rule. But pretty much, when you're taking the derivative, if it's not an x, you're going to put a d whatever to dx. Make sense? All right, now let's solve this explicitly. So that means let's solve it like this, like the way we know. So y squared equals x. I'm not doing anything. I'm just going to write it like this. Y equals square root of x. Well, let's see. How will we do it in the past? We would say that's x to the half. I haven't taken the derivative yet. And then I would go dy dx equals 1/2 x to the negative half. Do you guys agree? And then we would say dy dx equals 1 over 2 square root of x. And then maybe here you're saying, Chavez, that's not the same. How can you claim these are the same? They are the same. Y equals, what does y equal? So look at that, guys. Dy dx equals 1 over 2, since y is square root of x, y. OMG. What? That's supposed to be like teeth. Like what? I'm just making it worse. Okay, whatever. Isn't that cool? Yeah. Guys, virtual class. Wasn't that cool, guys?
Very.
I thought it was very cool too. Thank you, miss. Okay. Now we can do stuff like this. It says find the slope on a circle. Find the slope of this circle. How do we know it's a circle? Because it's centered at the origin with a radius of 5, right? Because it's x minus x naught squared plus y minus y naught squared equals r squared. That's the equation of a circle from algebra 2. Have you guys seen that before?
Yeah.
Okay, guys, don't scare me. That's from algebra 2, guys. The equation of a circle is that. Maybe you saw it in pre-cal. All right, here we go. I want to know the slope. How do I find the slope? What is slope? Yeah, changing y over changing x. So I'm looking for a dy dx. So that's what I want. I want a dy dx. I can't, it does not say y equals. So because it does not say y equals, I have to take the derivative implicit. Does that make sense? So here we go. I'm taking the derivative with respect to what letter? X. What's the derivative of x squared with respect to x? 2x. 2x dx dx, but you can leave the dx alone. Plus, well, it says y squared, 2y, and then what do I put next to it? dy dx equals 25 is a constant. What's the derivative of a constant? You're done. Now it just turns to algebra, guys. So here we go. I'm going to move the 2x to the right. 2y dy dx equals negative 2x. Are we still okay? I'm going to divide by 2y. So now I have dy dx equals negative x over y. Cool or not cool? You're going to catch on real quick. Next, dy dx evaluated at the point 3 comma negative 4 is equal to negative 3 over negative 4. So my slope is 3/4. And there it is. And it makes sense, guys. It makes sense. Chavez, what do you mean? I have a circle. And I'm at the point 3, negative 4. So I'm somewhere like right there. Look, that slope has to be positive. See? That tangent slope has to be positive. So positive 3/4. Cool or not cool? What's up? Yeah, let's do it. Let's do it. No, I want to. Do we have a lot of white space? Yes, we do. I think I did that on purpose. Check it out. So the question was, Ms. Tiff asked, is it okay? Well, I already told them. Ms. Tiff asked, what if we solved it like for y equals the square root of all that good stuff, like the old way? Well, let's do it the old way. X squared, oh, by the way, this is the new way, or the old way. X squared plus y squared equals 25. So let's move the x squared to the right. So y squared equals 25 minus x squared, square root. Y equals square root of 25 minus x squared, which can be written as 25 minus x squared to the half. All right, here's how we would have done it in the past. Dy dx equals, chain rule, 1/2, 25 minus x squared to the negative half times negative 2x. I see that half and that negative 2 go away. It's still negative though. Negative x over square root of 25 minus x squared. Let's see if we get the same answer. Do we get the same answer? Dy dx, evaluate it. I just have x's, but it doesn't matter. 3 comma negative 4 equals negative there, 3 on the top, square root. 20, oh, you know what? No, this square root should be plus minus. All right, we'll talk about that in a little bit, guys. You know what? Let's just talk about it right now. This 25 minus x squared, isn't that the same thing as just saying y? The square root of 25. So I'm going to say, that way we get the same answer. Negative x over y. So now look, finally, 3. This y value here, I'm just going to plug it in. Negative 4. Actually, no, there's no negative there. So now I get the same thing. Three-fourths. Why didn't what? Oh, I can tell you why, miss. This circle here, that equation is actually this equation. So the question Godina said is, why didn't it work with the square root in there? Because this bottom half is actually y equals the negative square root of 25 minus x squared. So because it's actually a negative, I should have had a negative here, and then I should have had a negative here, and then I should have had a negative on the outside, and then I would have had, if I would have plugged in a 3 in there, 25 minus 9 is 16, I would have had like that. And then negative divided by negative is a positive. So it would have worked, it's just that I messed up by putting the equation of positive square root of 25 minus x squared. That's the top half. I needed the bottom half of the circle. Does that make sense? Okay. Virtual class, are we doing okay?
I'm a little confused on why we multiply in the first one 2y times dy dx.
Because it's not an x. I'm taking the derivative with respect to x, not with respect to y. The derivative of y squared is 2y. If I were to tell you this, I'm taking the derivative with respect to y of y squared, then you would have just said that's just 2y. But I'm not taking the derivative of y squared with respect to y. I'm taking the derivative of y squared with respect to x. So the derivative of y squared with respect to x is 2y, and then dy dx. That y is like an inside. What did I just do? I took the derivative of the inside, which is dy dx. Did I answer your question, miss?
I think so. I think I'm gonna have to like think about. Oh, sorry if y'all heard that. I'm gonna have to think about it a little more. But
No, all you gotta know is if you're not taking the derivative with respect to x, it's gonna have a d something over dx because it's not an x. So if you have a t and I'm taking the derivative of t with respect to x, it's gonna be dt dx. If it was a t squared, it's gonna be 2t dt dx. So that's all you gotta know. If I'm taking the derivative, you gotta look at what I'm taking the derivative with respect to.
okay.
Cool? What's the question, Tiff? Yes, if I'm taking the derivative of everything with respect to y and I have an x, it would be dx dy. Okay, let's continue. I think the more practice we get, the better you're gonna get. It says show that the slope dy dx is defined at every point on the graph 2y equals x squared plus sine y. Okay, let's see what they're talking about. They want to make sure that I'm defined everywhere. So that means that I always have a real number. So let's just take a derivative and see what's up. Now, I'm taking the derivative with respect to what letter? X. So here we go. The derivative of 2y is, with respect to x, is what? 2 dy dx. Mazuka, did you get that?
Yes.
Okay. Equals, what's the derivative of x squared with respect to x? 2x. 2x dx dx, but dx dx is just 1. The nemesis of Godinez. Okay. Stop. Oh, I like that, miss. Plus the derivative of sine y with respect to x. What's the derivative of sine y? Cosine y? Is that an x? dy dx. Now, what we're going to do, we're going to get all the dy dx's together. So we're done with calculus. The rest is just algebra. So I'm going to move this to the left. So I'm going to write 2 dy dx minus cosine y dy dx equals 2x. Next, I'm going to factor out a dy dx. dy dx, factored out, 2 minus cosine y equals 2x. Perfect. To get it by itself, I'm going to divide. So dy dx is equal to 2x over 2 minus cosine y. Okay, I can see now that it's defined everywhere. Can you guys see how it's defined everywhere? It's okay, be honest. No? I hear soft piano music. I like piano music. Cosine y. Will cosine y ever be 2? No. So I'm gonna make a statement. dy dx is defined for all x and y since cosine y is between -1 and 1. Period. This means that 2 minus cosine y will never be 0. Hence, you know what? Turn that period into a comma. Hence, always defined. There it is. I like that question. I like it. I approve. Oh, it's because you weren't here in the beginning. Yeah, so you're going to have to wait a little bit. Or I guess we can catch you up really fast, maybe. Let's see. Okay, sorry, miss. All right, ready for the next question, guys? Guys, are you guys ready or no?
Yes.
Okay. Let me know if my computer starts lagging. It was lagging earlier, the internet. You can close the door, miss. You want to close the door? We got the windows open. That way the volume, we won't hear that volume stuff. But we got the windows open, so we're good. The windows are open and both ACs are blowing. All right, it says find the tangent and normal to the ellipse. So this is an ellipse, and here's my point, -1, 2. So I need two things for a tangent, and I need two things for a normal. Well, it's the same pretty much. What two things do I need? Point and a slope. I already have a point, so I need a slope. So here we go. I'm taking the derivative, but with respect to what letter? X. What's the derivative of x squared? 2x, because I'm taking the respect to x. Minus, and then if you, I guess it depends. You can group the minus with the negative x, but I prefer that you do it like this for now until you become really, really good. What rule do I got to use here? Product, perfect. Product first times derivative of the second. What's the derivative of y? dy dx. It's just y prime. Derivative of y is y prime, right? Yeah, 1 dy dx. Plus second times derivative of the first. What's the derivative of x with respect to x? 1. Close it. Plus, now, so here it is, Godinez. You're going to catch up right here really fast. I'm taking the derivative of y squared, but it's not. I'm not taking the derivative of y squared with respect to y. I'm taking the derivative of y squared with respect to x. So this, pretend this is like y like that. See? So 2, leave the inside alone, times the derivative of the inside. What's the derivative of y? dy dx. Do you see that? So it's like chain rule. Now do you see what we're doing? Okay, I'm going to erase it. Oh, you prefer that explanation? Okay. It's like chain rule. It's like saying 2, leave the inside alone, times the derivative of the inside. Equals, what's the derivative of 7? Done. Now your job is to get, now you're done with calculus. The job is to do algebra now. So this is why algebra is so important. Let's get the dy dx's together, get everything else to the other side. I'm going to distribute the negative. So here we go, guys. Negative x dy dx. And well, you know what? Okay, I'm going to confuse you guys. I'm going to write everything out. 2x minus x dy dx minus y plus 2y dy dx equals 0. And whatever does not have a dy dx, I'm moving it to the other side. And now I want to have a positive expression in the front, so I'm going to write 2y dy dx minus x dy dx equals y minus 2x. Does everyone see where I'm at right now, guys? I know that I'm like right behind this table next to the board, but does everyone see where I'm at, like in calculus wise? Okay. I know that wasn't funny. I apologize. I'll take it back. All right, next. I'm going to factor out a dy dx. So there's my dy dx factored out. 2y minus x equals y minus 2x. Next, I want to get the dy dx by itself. So I divide by whatever that factor is that I have next to it. So divide by 2y minus x. Divide by 2y minus x. Nothing cancels out other than the 2y minus x there. Dy dx equals y minus 2x over 2y minus x. Nothing cancels out, guys. There is nothing that you can factor out on any one, so that's the most common mistake I see from you guys. Now, what do I want? I wanted a slope, no? So I'm going to plug that in. So here's how you say it. You write dy dx, you write a little line, that line stands for evaluated at. Then I put -1, comma 2. And then I put equal sign, and then I'll go ahead and just start typing in what I have. 2 minus 2 times -1 over 2 times 2 minus -1. So let's see what we get there. 2 plus 2, 4. 4 plus 1. I got 4/5. Did you guys get 4/5? Okay, so here's my tangent line. So tangent line is y minus 2 equals 4/5 x plus 1. I'm going to leave it like that. Say it again. Normal line is y minus 2 equals -5/4 x plus 1. And I know you guys want to see this in Desmos, because I want to see it. Don't you guys want to see this? Okay. So you guys are going to have to tell me all this stuff. You know what? I should have done the other one too. Oh, no, the other one didn't have a tangent. All right, here we go, guys. Let's do it in Desmos. Ask. No, ask. Oh, they told me that when it says dy dx, you're looking at the bottom. You're taking the derivative with respect to x. Yes, because dy dx is slope, changing y over changing x. All right, guys, here's Desmos. Graphing calculator, C. I already forgot the equation. Can you guys hook me up? X squared minus xy plus y squared equals 7. There's my beautiful ellipse. Wow, look at that. I love Desmos. All right, give me my tangent. Oh, first let's put the point. What's the point at? -1, comma 2. There's my point. Now let's put the tangent. Y minus 2 equals, what was my slope? 4/5. And then was it, oh, go to the right. And then it was x plus 1. Yay, we are right. That definitely looks like a tangent. Let's look for the normal. I'm going to type in the same thing. Y minus 2 equals, put a little fraction, negative in the front. Maybe I should have done that first, or maybe it'll work like this. -5, yeah, it'll still work. -5/4, go to the right, parenthesis, x plus 1. Look at that. Look how beautiful that is. Thank you, Desmos, for giving us such beautiful graphs. I really appreciate you. Isn't that awesome, guys? Do I have your what? No, darn it. I'll email her right now. But today. And I see her all the time on Facebook. Virg Cornelius. All right. What does this mean right here? Second derivative. Are we up to it? Look, there's a whole page just for this. So it's probably going to take a page. All right, you guys ready? Here we go. I got to start by taking the first derivative. What's the derivative of 2x cubed with respect to x? Squared. Perfect. Done. That's it. We're done with the question. No, we're not done yet. All right. Minus, what's the derivative of 3y squared? 6y. Perfect. If you want to consider that y like the inside, you can. Equals, what's the derivative of 8? 0. You're done. You're going to get dy dx by itself. Move the 6x squared, -6y dy dx equals negative 6x squared. Divide by negative 6y. And you can cancel out what stuff canceled out. Dy dx equals negative x squared over y. I'm going to pair the negative with the x squared, guys. Oh, okay. Perfect. Thank you. The negatives cancel out. It's positive. Are we okay so far, guys? Now what rule do I have to use? Quotient. Here we go. The second derivative with respect to x equals, because that's what the derivative of dy dx is, second derivative, bottom, y, times derivative of the top, 2x, low d high, minus high d low, x squared, times derivative of the bottom, dy dx. All over, bottom squared, low, low. Low d high minus high d low. Are we still okay, guys? All right, now, you see this dy dx? I'm going to bring in that guy in there. So here we go. Second derivative with respect to x is 2xy minus x squared times x squared over y squared. So here's what I now have. 2xy minus x to the fourth over y squared. It's not proper to have it like this, guys. So here's what we're going to do. I'm going to put everything in blue that I'm inserting to balance. Because they probably won't have it like that as an answer choice, A, B, C, D. If it were free response and they just want a derivative, leave it alone. But if it were A, B, C, D, E, they will not have that answer. So what answer will they have? You see how I have a y in the bottom? It's x to the fourth over y? Turn that into y and then put a y squared. Do you guys see what I did there? So now, here's what I can do. Because I multiplied by y over y. So now, here's what you can do. You're going to have 2xy squared minus x to the fourth. Keep change flip. Y times y squared is y cubed. That's it. That's my second derivative. That's all they wanted. Where? Oh, you're talking about this? It's like saying this. I'm taking the derivative of a derivative. D squared over dx squared. Second derivative. Take the derivative of your derivative. You know what I mean? Now it's understood that it means that, but you always write it like without parentheses. How do we feel so far, guys? Okay, let's keep going. Another one. Another one. They want a second derivative again. So here we go. Oh, actually, you know what? Relax. Look, they already give us dy dx. So we don't have to do all that work. So now we can just go right into it. Second derivative equals, what's the derivative of 1? 0. What's the derivative of sine y? Cosine y. What do I put next to it? Dy dx. Let's put what dy dx is. Cosine y. And then I'm going to put right 1 plus sine y. Is that answer in there anywhere? I'm going to have to distribute it. It's in there, guys. Cosine y plus cosine y, sine y. Which one is it? E. All right, that was the last one. I thought that was going to give us harder. All right, let's come back, guys.